To begin with, I will take one problem on rectifier. In last session also, I took one problem from rectifier. So here we need to compute the fundamental component of source current. And this problem was asked this year only, 2022, for 2 marks. And here, AC to DC rectifier, can you recognize which type of rectifier is this?
Symmetric rectifier.
Yeah, symmetric semi-converter, you can say. So here we will draw the waveform of the current and voltages, and then we can easily find out the whatever is asked. So let me draw. So input sinusoidal signal is provided, Vs, and based on this, so from alpha to pi, uh, let us say T1, D1, T2, D2. So from alpha to pi, T1 and D1 will conduct. Okay. And from pi to pi plus alpha, since this diode will be off after pi, so diode D2 will try to freewheel the current. Since no any freewheeling diode explicitly provided, so current will try to freewheel through D2 and T1 and it will short the source. So current will flow in this manner from alpha to pi plus alpha. And the devices which will be turned on during this period would be T1 and D2. After that, pi plus alpha to 2 pi, at pi plus alpha, this T2 will get turned on. So T2 will conduct and D2 anyway will conduct because that is uncontrolled switch. So in this manner, I will draw one more, or I will write for one more instance that 2 pi 2, 2 pi plus alpha, or you can say 0 to alpha, both is same. And here D1 will start and T2 was already conducting. So from 0 to alpha, this D1, T2 will freewheel the load current. So now we all know that which devices will conduct for which instance. So based on that, we will draw. This is omega t axis. So here alpha is 45 degree. It is provided in the problem. So we will draw for that. V naught. This is the waveform of V naught. And had it been a full bridge rectifier controlled, or had it been all the devices be thyristor, then this could have gone to the negative axis to satisfy the criteria. What is the criteria here? The criteria is here that load current is constant or the load current is ripple free, that is 15 ampere and ripple free. It means that current is continuous, and to maintain that current, here devices would conduct continuously. But since diodes are given here, so current will conduct through load side, but it will not be continuous on source side. So, and when diode will conduct, so you can see the voltage across load would be zero since a short circuiting is happening here. So plus minus, you can see this voltage will be zero during T2 and D1 will conduct, and when T1 and D2 will conduct. So this voltage will end here, and after that, when T2 get turned on at pi plus alpha, it will follow the same supply but in reverse manner. And let me write the device's name which will conduct. So here D1 D1, here D2 D2, here T1, sorry, T1 D2, and here T2, sorry, here T2 D2, here T1 T2. So actually we need to find the current waveform from source side, but until we know which kind of pattern is there, we can't exactly know how the source current will flow. So now we know this voltage waveform and when source will conduct. So for that purpose, now I can easily draw the source waveform, right? How? When T1 and D1 will conduct, so source current is equal to IDC. So when T1 and D1 is conducting, IS is equal to IDC. And when this freewheeling condition is being satisfied, then no current is being drawn from the source. So only load current is freewheeling and source current would be zero. So for this period, IS would be zero. And for this period, IS would be zero. But here, IS will have IDC, but in negative side. When T2 and D2 will conduct, then IDC is equal to minus IS. So that you can visualize from this circuit. So that's why this all waveform and drawing was important. So now I can easily draw the current waveform of IS. So from alpha to pi, IS would be equal to I naught, and from pi plus alpha to 2 pi, Is would be equal to minus I naught. Okay. So this is the waveform of semi-converter, as you can see, and it's fundamental we need to find out so that it would have some sinusoidal component. Alpha to pi, but to get even symmetric, we can shift it towards uh, we can make it as a half wave symmetry. To make it, we can shift it by alpha by 2 so that it will be symmetric across this pi axis. So to do that, alpha by 2, pi minus alpha by 2, pi plus alpha by 2, 2 pi minus alpha by 2. So it is symmetric about this pi axis. We made it symmetric so that we can easily compute the Fourier series of this waveform. And now its Fourier series will be this symmetric 2 pi. And that factor, since in full bridge thyristor based rectifier, when source is not freewheeling, when source is continuously conducting, then this square would have been a full square wave kind of thing. But now some portion get chopped off. So that portion would reflect in its formulae or its expression. So earlier its expression was like Is is equal to summation 135 to infinite or I naught by n pi sine n omega t. Now, this expression will have some factor of alpha because it gets shifted by alpha and it gets chopped by alpha. So for that reason, that cos n alpha by 2 comes in the expression. And again, and now this is not original waveform. The original waveform is this one, which was shifted by alpha by 2. For that reason only, it will reflect in this expression minus, sorry, plus alpha by 2. Because this waveform got shifted by alpha by 2 towards left. So that's why I am doing plus alpha by 2. So any confusion till this point? So if not, then I
No,
will,
sir.
thanks. So then I will move on. Huh. Now I can calculate IS1 from this expression easily. So for that reason, IS1 will be equal to 4I naught by pi cos alpha by 2, and this will be magnitude, and sine n omega t plus alpha by 2 would be its angle. So we only need magnitude since we can see the problem here. This I naught is given 15 ampere and alpha is given 45 degree. So we just need to compute the amplitude of fundamental component of the source current. So that I will do here. So it will be equal to 4 into 15 by pi cos 45 by 2. So after calculating this, let me compute this. 3 by pi 2 cos 45 by 2. So it will come around 17.64 ampere. So that will be the magnitude of source current, fundamental component of source current.